Okay, maybe just a little review. Ions. Who can tell me what an ion is?
The charge over
The charged atom, right? So we got ions or charged atoms. And we talked about this. If you don't want to write it down, you don't have to. There's two types of ions. What are they?
positive and negative.
Positive and negative. That's right. Which ones are positive?
One valence electron or two valence.
What do we call the positive ions? Cations. So we got cations. Cations has a plus in it, right? Did I show you that? So cations have a positive in it. It's the T. So this is the positive ion. And the anions don't. And that's the negative. Are we good? Okay. And who can tell me what the octet rule is? Kind of talked about it earlier today. It's where atoms tend to do what?
They want to fill the shell, they want to get like
Yeah.
8 electrons.
8 valence electrons, right? Not just electrons, but 8 valence electrons, the ones on the outside. Okay? And just like the noble gases. Why do they do that? Because it's all balanced. Okay? And it takes less energy to do that. And then valence electrons are the electrons on the outside. Good? Do you remember how to determine how many valence electrons there are in atoms, in the main group elements? Everybody get your periodic table out? How many valence electrons does lithium have? Lithium is number 3. Go ahead. When you have it, tell me. How many valence electrons does lithium have? 1. Everybody else scared? Just kidding. Okay? It is scary to talk in front of people. I know. So good. It is 1 because it's in group 1, right? What about nitrogen? Number 7. 5. Because it's in group 15, right? Okay, we can tell by looking at the periodic table for just the main group elements, not the transition metals or the intertransition metals, right? Okay. All right. Let's move on to ionic compounds. Compounds. What are ionic compounds formed of, would you guess? Good guess, not quite. I'll give you a hint. It's in the name, yeah.
Is it the ratio of different?
It is a ratio of what?
Different elements?
What different elements are we talking about? Ions. Different, it's made of ions. Hence we call it ionic compound. Are you good? Okay. So it's made of, consists of, so know these several points I'm going to give up. Consists of a cation and an anion. One of each. Why? Because opposites do what? Attract. They attract and bond together. Good? Okay, another one. Ionic compounds have metals in them. If a compound has a metal in it, it is, without exception, an ionic compound. Okay, there are some ionic compounds that don't have metals in it. but most of them do. And if it does have a metal in it, it's an ionic compound. Because you'll be asked on the test how to differentiate between an ionic compound and the other kind, which is a covalent compound we'll talk about next time. Okay? All ionic compounds are neutral. So even though they have both positive and negatives, they have to match up. Okay, and we'll talk about that in a minute. Another name for ionic compounds, these are called salts. And what happens, so the salt that we know that we eat every day is specifically called sodium chloride. But what do we know about salt when you throw it in water? It dissolves, right? And what happens when salt dissolves on the molecular level? What happens is, I'm just going to draw this little container here. You got water in there, and I have this sodium chloride, and I'm going to throw it in here. Well, it splits back apart. So originally, how many valence electrons does sodium have? Look at the periodic table. Sodium is number 11. 1 valence electron. How many does chlorine have? Chlorine's number 17, I think, yeah. 7. So chlorine has 7. 1, 2, 3, 4, 5, 6, 7. I'm not drawing all the electrons, just the valence electrons, right? Well, what does chlorine want to do? Get one more to have 8, right? What does sodium want to do? Get rid of 1 so that it can go back to its last level and have 8, right? So this electron comes over here, and when this happens, this becomes negative, this becomes positive. And then they attract, right? You with me? Well, when you throw it in water, it dissociates. It comes apart again. We won't talk about why right now, but we will eventually, okay? But it just dissociates and becomes sodium ion and chloride ion in the water. And it turns into an electrolyte. You guys ever heard of electrolytes? On commercials on TV, they talk about electrolytes. What's a good example of an electrolyte? Anybody know? Gatorade, right? Well, that's just something they tell you. Well, it is an electrolyte, but it also has sugar and stuff in it, maybe not great for your body. If you want a more healthier one, just have lemon water. Lemon water is an electrolyte, okay? Because lemon juice is an acid, and an acid is an ionic compound. It dissociates, okay? Don't worry about what I just said there. You don't have to know about acids yet, okay? So why do we call it electrolyte? It has charges in there. It's more conductive to electricity than just regular water. Tap water also has ions in it, so tap water itself is an electrolyte. Not a great one because it's mostly water, but there's chloride and fluoride in it. I don't know if you've heard about that, right? Okay. Any questions about what ionic compounds are? Okay, let's see what else. They're crystalline solids at room temperature. Let's write that down. just like salt is, right? Looks like a crystal. They are, and this you need to know for the next test. They are not conductive by themselves as a solid, but if you melt it or put it in water, then it becomes highly conductive. Okay? Or higher, not as much as a metal probably, but it becomes conductive. So it's non-conductive as a solid, but conductive when melted or dissolved. Well, that green's kind of bad, huh? I need to quit using that. Is that orange okay? Yeah. All right. Are we good? Having a good idea what ionic compounds are? How do we tell if a compound is ionic? Good? Okay, let's move on. Okay, so we talked about an ionic compound has a metal and a nonmetal, right? Or if it has a metal in it, it's ionic compound. So the metal will lose an electron and become what? A cation. The metal will become a cation. If you look on the periodic table, it's easy to tell, right? The nearest noble gas to the metals, it's going to lose electrons so that it can be like the nearest noble gas, right? And nonmetals will gain electrons and become anions. So for an ionic compound to form, electrons are transferred. Okay? And why are they transferred? For one reason. So that each atom in the compound can have the octet. Okay, they do this to complete the octet. One of them's not going to, one of them's not going to give one up if they can't be, if it's not going to help the other one, right? So what about calcium with chlorine? We know that all ionic compounds are neutral. What's calcium going to do? Look at the periodic table. Calcium is number what?
We lose 2 electrons.
It's going to lose 2 electrons. It's a metal, right? And become what? Calcium 2 plus, right? And chlorine is going to gain how many? 1 electron and become 1 minus. Do you understand why losing is positive and gaining is negative? Don't just think, oh, it's just opposite what you think, right? Are we good? Okay. All right, now, all ionic compounds are neutral. Is that going to be neutral if we have one of each of those? No, so what does that mean? They want to have the octet. This guy has to be positive 2 to have the octet. This guy has to be negative 1 to have the octet. So can you have a compound with calcium and chlorine in it? Yes, this is stuff we throw on the road during wintertime. Ice melt. It's a compound. Do you get shocked when you touch that stuff? No, it's neutral. So how do we make this neutral? That's it. You got 2 of those guys. And so this is what? CaCl2. Do you get that? I'm going to show you a little trick on how to do that. So let's do that next. But it's just, that's what happens. It has to do whatever it needs to do. Because if there's chlorine nearby, how many chlorine atoms are there really? Trillions of them. In one breath, you got trillions of molecules, right? Same thing. Atoms are so small, if you have it, you have trillions of them. Okay? So if you have one, you have more than one to work with. So let's show you how to write chemical formulas for ionic compounds. Yep, that's it. Writing. I'll show you. Yeah. I'll give you all the steps and what you have to do. If you follow these steps, you'll get it right every time. Writing chemical formulas for ionic compounds. And later, we'll talk about covalent compounds. It's different. So you have to know the two, and you have to be able to differentiate between the two, okay? So write these steps down. So step 1 is we write the cation formula first. Step 2, and we'll do this. Write the anion formula second. Remember, all ionic compounds has a cation and an anion, right? And step 3, we cross the charges, or just the numbers, right? Cross the charge. And the last step, step 4, simplify. Because all ionic compounds must be written as with lowest whole number ratio of elements or of atoms. Maybe we should write that in our, sorry. We'll just write it right here. Simplify because all ionic compounds are written with lowest, sorry guys, lowest whole number ratio. Okay? And they have to be. Why? Because they don't want to use too much energy. Keep it simple. Okay, so let's do some. So if we have an example, a compound with magnesium and oxygen. Okay, first step is write the cation formula first. Which one is the cation out of magnesium and oxygen?
Two positive, two negative.
I can't tell. They're not, I didn't give it to you. So which one is positive? Which one is the cation?
Magnesium,
Why?
they have two valence electrons.
Yeah, they have to give away 2 electrons, and it's a metal, right? Metal is the cation. Good. So Mg, and what's the charge? So we have to write the cation formula. What's the formula for magnesium cation? Mg2 plus. Y'all with me? Do y'all understand how to get that from the periodic table? Okay? And what's oxygen? 2 minus, right? And notice we put the plus and the minus after the number, right? Why do we do that? Because whoever started it did it that way and it stuck. No other reason, okay? But that's the way we do it. Okay, now we wrote cation first, then the anion. Now what do? Cross these, not multiply, just cross the numbers over. So we got Mg2O2. Well, step 4 says to simplify. This is a 2 to 2 ratio. Can we simplify that ratio? Has to be lowest whole number ratio of 1 to 1. MgO. That is the only way magnesium oxide occurs. Okay? Questions? Should do a couple more? Okay, so we got nitrogen and calcium. Use your periodic table. And which one is the cation? Everybody besides Vir.
Calcium?
Calcium is the cation because
It's in the 2 plus? Or it's got
it's
more?
in group 2 and it's a metal. Yeah. Good. It's the nearest noble gas, means it's going to lose 2 electrons. Good. All of those are the right answers. So we got calcium as our first one, and it's 2 plus. That means nitrogen must be an anion, which is
3 minus.
3 minus. You can participate now, Vera. It's just I just wanted to make sure we all got this. And now we know 2 of you got it. No. All right. What's our next step? Well, look at the steps. We wrote the cation first, the anion second, then we cross the charges, right? Y'all with me? That 3 goes down here, and this 2 goes down here, making it Ca3N2. And what's our last step? Simplify. What's the ratio right now?
3 over 2?
3 to 2. Can that be simplified?
No.
No, then we're done. Good? So that's the chemical formula for calcium nitride.
Calcium nitrate. Is it nitrate?
Nitride. We'll get there. I'll teach you how to name them and everything. That way, when you go take care of business in the bathroom, reading your shampoo bottles, you know what they're talking about, right? No, I'm just teasing. Okay. Are we good? Do we need another one? Okay, moving on. So, let's give you a harder problem that will be on the test. I'm not talking about test 1, I'm talking about test 2, right? So are you guys going to take test 1 in the next couple of days?
I need more time to study, so I think Thursday.
Okay, sounds good. Any time this week would be good. But don't get behind. Don't. Anyway. So let's say we have a compound that has a chemical formula of XCl2. And we know the X ion, so we know this is an ionic compound. And X happens to be what kind of element? Is it a noble gas? If it's an ionic compound, what kind of element is most likely X? A metal, right? Because it's the first one. It's the cation. Good? So the X ion, let's say, has 20 electrons. The X ion has 20 electrons. We want to know, what is X? What? Calcium? Good guess. Because calcium has 20 electrons if what? If it's neutral.
But
Is X ion neutral?
no, it has
Why is it not neutral?
+2
I don't know.
on the
Why is it not neutral?
on the anion.
Because it's an ion. This is X ion. It must be charged, right? That means it either lost electrons or gained electrons. What did it do? It lost electrons. How do we tell? Is it 2? There's a couple ways we can do this, guys. We can cross these numbers back up. There's only one bad thing about doing it this way. We have to simplify when we're done, don't we? Who knows? Is this simplified? We don't know because we don't know what X is. But if we do this, it's X2 plus and Cl1 minus. Is that the correct charge for chlorine? It is. That means this also is correct. Okay? So if you do it that way, you have to make sure that it wasn't simplified first. Should I show you a way that if you do it this way, then you'll never go wrong? This is the way I like to do it. Well, we have XCl2, and I put a line between the cation and the anion, and this is just to organize it, right? And put a line underneath it. You don't have to do this physically. It's just a way to organize it. But if you can see it without doing it, great. And what's the charge of, do we have to know the charge of one of them? Do we know the charge of chlorine?
Yeah.
1 minus, right? And how many chlorine atoms are there? There's 2 of them. So if each one has a -1 charge, this has a total charge of what? -2. And all ionic compounds are neutral, so that means all of the cations has to have a charge of +2. The exact opposite of that, right? And how many X ions are there in this compound? What number is right there?
An invisible 1.
Oh, there's no number, so that means there's 1, right? That means it takes all of the charge. If it was a 2, it'd have to cut it in half, right? So it's a 2 plus. We got the same thing either way, right? So there is more than one way to do things. So find a way that you like. Just make sure if you do it this way, you double check to make sure this one is correct. If it's not correct, what can you do? You multiply it by whatever number makes it correct. But you have to multiply it by this one and this one. You with me? So do it this way, you don't have to worry about checking. That's why I like it. Okay? All right, so that means this X2 plus ion has 20 electrons. What happened so what is the X element? How many electrons does the X element have? It has 20 after it becomes an ion. What is it before it becomes an ion?
Neutral.
It got rid of 2 electrons, and now it has 20. You following me? If it got rid of 2 and has 20, how many did it have before it got rid of 2? I'm going to say it again. If it got rid of 2, and now it has 20 after it got rid of 2, how many did it have before it got rid of 2?
22.
22. Are you with me? This is the element, not the ion. So what neutral element has 22 electrons? The one that has 22 protons, right? When they're neutral, the number of electrons and protons are the same. We learned about that, right? So this is titanium. So that means it's TiCl2. Are we good? Yeah, question.
Can we do another example?
Yeah, we can. Because, yeah, there's one of these on the test, there's one on the midterm, and there's one on the final. You're going to have to know this for the rest. Okay? So let me pull a periodic table out so I'm not just guessing. Here. All right, let's say we have X I'm going to make it a little bit harder. XS2, and the X ion has 78 electrons. What is X? Go ahead, try this.
Wait, how did we know the chlorine had a -1?
Because it's in group 17.
Right.
That means it has 7 valence electrons. It needs 1 more to have 8. That means it's -1. You with me?
Yeah.
Good question. Always ask if you're not sure.
There is no +4, is there?
Not looking at the periodic table, no. So don't do it that way.
Okay.
Do it the way I showed you.
No, I was doing it the way you showed me.
Oh, okay.
That's why I'm so confused.
You guys ready to do it? Or does anybody have it? Who knows? What is it?
Lead.
It is lead. Okay, let's go through it. Okay, so we have XS2, and I'm going to figure out what the charge of X is. And I guess you found what it is, +4, right?
Yeah?
Okay, so sulfur has a charge of what? It's in group 16, so it has a charge of
-2.
-2. And how many are there?
2?
There's 2 of them. All the sulfurs has a total charge of -4. And how many X ions are there?
Positive.
There's just, well, this has to have a +4, right? To be an ionic compound. And there's only 1 of them, so it takes the whole charge. So that means it's +4, The X4 plus ion has 78 electrons. So what does X have?
82 electrons.
Well, it got rid of 4 to have 78. That means it has to have 82 before it got rid of 4. Make sense? And what else has 82 electrons if it's neutral? Lead, because it has 82 protons. So this is lead 4 plus, sulfur 2 minus. Cross the charges, and we get Pb2S4. Simplify it. That's PbS2, and that matches. Good?
Hold on.
I'm holding.
Okay.
Does this make sense to everybody?
It's starting to.
Okay. So you have to know what the charge means. It means it lost or gained electrons, right? And the number means that's how many it lost or gained.
Where did the 4 go in that?
It went down here,
Oh, that's the simplified.
but you have to simplify it. Don't forget to if you do the cross method. In fact, do you want me to show you how it really happens? Because do you think what really happens is they cross charges? No. Let me show you what really happens. We got Pb 4 plus and S2 minus. Well, you look at these two; they come together, and this happens instantaneously, not as slow as I'm going to do it. But lead, if you take one of those and one of those, you have positive 4 and negative 2. What's that charge add up to? Positive 2, right? That means we need more of these or more of those. Of those, right? The negative 2s. If you have one more negative 2, that makes it 0. That means it's done. So we have 2 of those and 1 of those. Pb, 1 of those and 2 of those. Didn't have to simplify. But do you see where crossing it and simplifying might be faster? Again, we're not for speed, but so you can do it that way if you want. Just find out how many you have to have before to make it neutral. The lowest number. Question?
Do it ask for like for the second element too? Like find the second element X.
Do what?
Like it's always natural or it's always the first element to be find. So we should have to find the second element too.
Oh, like a problem on the test? You could.
And show an
If
example for the second one.
yeah. There's one on the final like this. So let's, and it's going to be simpler, but here we go. Let's say we have Fe2X3, and it says X is a gas at room temperature. What is X? By the way, this is on the final, ladies and gentlemen.
Is it one of the noble gases?
That's a good question. We can't just guess. If you're guessing, you're getting it wrong, most likely. Don't guess.
Oxygen.
So we do the same thing. Do we know the charge of this? Actually, I can't give you that one. That's wrong. I won't give you this one. It won't be this one. Let me do a different one. No, not Fe. I just said I can't do that. Let's say we have Al2x3. There we go. This one will work. Okay, so we got to do the same thing. Do we know the charge of aluminum? What is it? 3 plus. And there's how many aluminums? 2. That means it's a total charge of positive 6. That means the anions have to have a total charge of negative 6. There's 3 of those, so we have to cut negative 6 into 3, making it 2 minus. So we know our anion, or our nonmetal, is negative 2 charge, and we also know it's a gas. Where's our negative 2 anions located?
So it's either,
In group 16, right? So it could be oxygen, sulfur, and going down. Which one do we know is a gas? Oxygen. I hope we know that. We breathe it. We have to have it, right? I just gave you the answer to one of the final questions on the final exam, okay? There you go. But otherwise, it's mostly going to be the metal. Okay? Questions? Okay, let's move on. Yeah.
How did you know the X was a negative 2 charge?
On this one?
Yeah.
Because we knew this one's positive 3, right? And there's 2 of those. So positive 3 multiplied 2 is positive 6. You with me? Are you with me?
Yeah.
Okay. And so this side has to be negative 6 to be neutral, because all ionic compounds are neutral. And there's 3 of them, so 6 divided by 3 is negative 2. Did that make sense?
Yeah.
Good. Thanks for asking. We all good? All right, let's move on to another type of ion. And ladies and gentlemen, you get, on the midterm and the final, you get a 1-sheet double-sided page of notes. I would have these on that sheet. The other option is you memorize them. And there's a lot of them. I should have printed this out for you.
is it up there on the table over there?
It's not. I should have printed it out for you, but I didn't. You want to write them all down? Oh, it's okay. I wrote them down in the past. It's fine. Or should I give you a picture of what they look like, and then I can give you a copy next time, or put it on Canvas? Would that be better?
Yeah,
Or do you want to write all these down? Okay.
we can write them down in our own time.
All right. So yeah, let's pull them up. Okay, it's hard to see this, so can you see that? All right. So we're just going to go through these quickly, because you're going to have this sheet and you can look at them and refer to them, yeah? But if you want this page on your, I'm going to give you a whole page. It looks like this, right? That's a whole one side. That's one side of, you don't want it that big, right? You make it smaller? Okay. But, so you can either write them or make it smaller on a digital copy, right? All right, here we go. So ammonium is NH4. This is one of the 2 ions that are cations. but don't have a metal in them. So remember I says ionic compounds, it has a metal in it, it's an ionic compound, right? But if it has one of these two in it, it's also an ionic compound. And this one is the same as H+. So when we start talking about acids, well, that's in it. Okay? So if the compound has either ammonia, hydrogen, or H3O+, it is also an ionic compound. So you got to be, you don't have to memorize all this stuff, but you got to be familiar with them so that you can just, yeah, I know that's a polyatomic ion. I know where to look on my sheet. But if you don't know that it's a polyatomic ion, you don't know where to look. You're just like, oh, what is this, right? So make sure you don't just, oh, yeah, we get this on our test, I'll be fine. Same thing with the periodic table. Oh, we get this on our test, I don't have to look at these. Study these. Get these down. I'm not saying memorize them, be familiar with them. Good? All right. So we got peroxide. You've heard of hydrogen peroxide, right? Well, hydrogen peroxide is H plus and O2, 2 minus. We know how to cross this, right? Cross the charges. Brings a 2 down here, 1 here, and it's H2O2. That's hydrogen peroxide. Good? We got hydroxide is OH minus. Acetate, which is a part of vinegar with H plus. It's acetic acid. Cyanide, I'm sure you've heard of that. That's what they use in, what?
Poison.
It is poison. That's what they use in, what is it? Chemotherapy. Okay. They try to kill those, but along with killing the cancer cells, they kill the healthy cells too. That's why they lose their hair, right? Okay. Azide is not real familiar or common. Carbonate, bicarbonate. So this is the stuff in baking soda. Sometimes it's called hydrogen carbonate, but we'll just keep it as bicarbonate. Nitrate, nitrite, know the difference? One's 8, one's ite. This one's, if it's ite, it has 1 less oxygen than the 8. That might be useful. We got sulfate and sulfite, same thing. 1 less oxygen. Charges are the same. You don't have to memorize them, they're right here. Hydrogen sulfate. Notice what happens in hydrogen sulfate and hydrogen carbonate or bicarbonate. H plus and CO3, so carbonate is CO3 2 minus. If you have a positive with a negative 2, it becomes a negative 1. And again, you don't have to memorize these, but I'm just showing you how it came to be that, yeah? In fact, when I say you don't have to memorize them, you do have to know these, ladies and gentlemen. You do. If you want to have a cheat sheet that you can look at, that's okay. But you have to know them. I'm not going to tell you what nitrate is. You have to know what it is or find out what it is. Good? And then you got hydrogen sulfate, phosphate, hydrogen phosphate, dihydrogen phosphate, perchlorate. So notice the difference here. We have a per in front of it. That means 1 extra oxygen. Still ends in ATE. Chlorite, 1 less oxygen than the 8. Hypo means another 1 less. So it's hypo and ite. That means it has 2 less. And just things to help you to remember what they are, but again, you don't have to. Chromate, dichromate. Can you see these okay? Do I need to make it bigger? Good. Okay. Permanganate. And then you got These are acids. We'll talk about those later. So all of these acids we'll do later. So, that's cool. I didn't realize the acids were on there. These are our polyatomic ions. And these right here are the acids. We'll talk about those later. And you will have to know how to name those. Okay? Or you can use this, right? Any questions about polyatomic ions? Yeah, let's give you a definition, right? Poly, what does poly mean? Many, more than one, right? Just like polygon, right? So, many atoms there we go. Polyatomic many or more than one element in a compound or in an ion. Good? And on the worksheet that I gave you, it says write the charge of them. Again, that's not going to be useful if you're just going to have the sheet. You could just look at it and whatever. But if you're going to go on to chemistry, do more with chemistry, like in medical, then you might want to memorize these. Okay? If anybody going to go into medical, you might want to memorize these because you're going to have to take a higher chemistry where you have to memorize them and you won't get them to look at. So consider that, okay? And I can show you a method to memorize some of them, but you let me know. Otherwise, I won't. Okay? All right, an oxyanion is a polyatomic ion with oxygen in it. So, for example, we have nitrate, we have carbonate, phosphate, sulfate. Okay. More than that, but those are some examples. Good? Okay. So let's write the chemical formula with a polyatomic ion in it. Okay, it's the same steps, guys. No different. So if we have one with, let's say, magnesium and chlorate. So magnesium, first step is write the cation first with the charge, right? So magnesium is Mg. What? What's the charge of magnesium? Look at the periodic table and you won't have to guess. 2+, right? always use your periodic table. And when you get this polyatomic ion sheet, always use the polyatomic ion sheet. Even if you think you got it, guys. If you have the sheet there, use it. Make sure it's right. Okay? And chlorate is ClO3 minus, and you'll be able to look on the polyatomic ion sheet, right? That I'll give you. What's our next step? What's our next step on when we did this before?
Crossover?
Cross the charges. Right? And we got Mg. Do we need to write the 1? No. We got ClO3 2. What do we need? Parenthesis. We don't want 32 oxygens. So for polyatomic ions, if there's more than one, we must have parentheses. Can we just always put parentheses around the polyatomic ion? Would that be okay? What if we have, let's say, sodium and chlorate? This is going to be NaClO3. We can either write it like that, and that's commonly what it's written as. Can we also write it like, come on, can we write it like that? No problem. If you want to just always include parentheses for polyatomic ions, you can, so you don't forget. Are we good with writing chemical formulas with polyatomic ions in it? Okay. Let's learn how to name ionic compounds. Okay, step 1. Name cation first. Makes sense because it's written first, right? And how do we name it? As the element name. Step 2. Name anion second. Makes sense? By changing element name, element ending to IDE. And I have a little note here. If cation or anion is polyatomic, just use polyatomic name. We're not going to change the ending to IDE on polyatomic ions. We're just going to use the name. Is there something you can't read? Oh, it's hard to read it? Thanks for letting me know. Okay, so the note here, is it hard to read anything up there? Is it just that color? Okay. So if ions, both cation and anion, are polyatomic, use polyatomic ion name. you read that? Better? Okay. All right, let's try some. Okay, example 1. We have SR3 and 2. What's this called? What's SR called? Look at your periodic table. You don't have to memorize this. It's in group 2, but I won't tell you that on the test. Make sure you become familiar with them. Strontium, we just use the element name. And what's the name of that guy?
Nitrite.
So it's normally nitrogen, but it's an anion. We change the ending to IDE. And why isn't it nitrogide? Because it sounds goofy and there's too many syllables.
Because there's two oxygen, or
No oxygens.
there's,
Two elements of nitrogen.
Too many syllables. And it's just a name, guys. So why did we choose this name? Because somebody did and it stuck. That's really why. Okay. Should we do another one? Does that make sense to everybody? Yes or no? Okay. You got NH4 2SO4. What's that called? Oh, you guys don't have this list. This is called ammonium, right? And this is called sulfate. So we just use the polyatomic ion names. That's it. Make sense? Oh, I used orange again. Oh. Sorry. Gosh. I need to just change that right now. Can you see pink? No?
maybe like a hotter pink, if that makes sense.
That's as hot as it gets. No.
Or like a really dark forest green. Or
Is that better? Okay. Questions? All right. One more type of compound, ionic compounds. And these are with transition metals. Told you I was going to talk about these later. We don't know what the charge is because it's not main group elements, right? So ionic compounds, is that okay? That color or no? Still no.
ooh, what if you did purple?
I already have a purple.
Oh,
I did go with purple. So compounds with transition metals. And remember, transition metals, or I don't know if I didn't tell you this yet. Transition metals are variable cations, meaning they have more than one charge. So, should I have you memorize all these? No, I'm not going to. Why? Oh, because that's dumb, right? I don't even memorize them. But for example, for copper, we have copper 1+ and copper 2+. You don't have to memorize this. I'll just show you how you figure this out. Okay? So if we have copper oxide, then it could be Cu1 plus and O2 minus, or it could be Cu2 plus and O2 minus. And if we write the chemical formulas, it's going to be Cu2O and CuO. Which one are we going to call copper oxide?
First one, Cu2O.
Neither of them. Right? And you can't call them both copper oxide. So we have different names. So once we know the charge, we do the same thing, cross them and simplify, right? That didn't change. But when we name ionic compounds with transition metals in them, we have to include what the charge is. So here we do it. Here's how we do it. We have name this one just like normal. It's copper. Name this one, change the ending to IDE. But we put parentheses right after the transition metal, and we use Roman numeral to represent the charge. Well, this is a 1 plus charge, so it's Roman numeral 1. You with me? Do we remember our Roman numerals? All you have to know is up to 8. Who needs me to go over Roman numerals? Nobody? Okay. So what is this one called? It's not called copper dioxide. Good guess, though. It's called copper. Still an ionic compound. That's oxide. What's the charge? 2, so it's Roman numeral 2. Copper 2 oxide. That's how we call it. Copper 1 oxide, copper 2 oxide. And if we're given this and we have to write the chemical formula, how do we do that? Well, we know it's copper, Cu, is 2 plus, and oxide we know is 2 minus from the periodic table. We cross the charges and simplify. Are we good? Yes? No? We're not sure? Okay. Let's do I'm going to do, let's see. I'm going to do one that's a common mistake people make. And that is, let's say we have CuSO. Yeah, let's say we have CuSO4. And we got to know the name of this compound. We have to know the name of that charge, right? Or sorry, we would have to know the charge of that ion. And we don't know it. We have to figure it out. Do you remember how we figured it out? What? Well, let's find out. Let's find out. Do we know the charge of, what is this? Sulfate. So we look on our periodic table, or on our sheet, and it's 2 minus. How many are there? I'm hearing 4. Are there 4 of them?
1.
Why is there only 1? Because there's no parenthesis. A lot of students say that there's 4 of them. That is a part of the sulfate ion. There's only 1, so it's -2. 1 times -2 is -2. This side has to be +2. In copper, there's only 1 copper, so it's 2 plus. So this CuSO4 is called copper 2 sulfate. Common misconception or common mistake people make. Good? So just write that down. If there's no parenthesis on a polyatomic ion, there's only one of them. If there is a parenthesis, well, then it's easy to tell how many there are because it's written there. Good? We got caught up, ladies and gentlemen. Whew. Well, kind of. It still says we're Russian and Russian and Russian, but we're still Americans. No, sorry. I'm not going to do any more tonight, though. Any questions for tonight? Okay, let me tell you something else. This stuff, people either get it or don't get it, but this is going to be used for the rest of the semester. And if you don't retain this information, this class is just going to get really, really hard. Get it down. Study it. If you're not studying 6 to 9 hours a week, start studying 6 to 9 hours a week and get this stuff down. Okay? And I just put in scores, and a lot of you are not doing critical chemistry. I mean, your score is going way down. If you didn't do any, you're failing. No big deal. Just start getting caught up. Start with what we're doing right now and gradually get caught up. Don't start with back then and get caught up that way. Start with what we're doing now and go back to get caught up. Good? Okay. I know it's summertime and we want to be outside and do whatever, but you also want a good grade, I'm sure. So let me know what I can do to help, and let's have a great rest of your night. Does anybody want me to go upstairs and make copies of this chart right now? And you'll wait for it and you'll pick it up? Okay, I can go do that. If everybody leaves, please shut this door so no one steals my stuff, okay? But I'll go get this, put it out, take it 5 minutes. Sorry, I should have had that before.
Thank you.
Thank you, take care.